Okay, so we have here now the description to calculate the E of the cell when the system or the cell is not at standard condition, which is a function of the E naught of the cell, the potential at standard condition, minus RT over 2F times ln activity of zinc 2 plus over copper 2 plus. This is called the Nernst equation, right? The Nernst equation. So if you were to plot this Nernst equation, having the y-axis to be the E of the cell and the x-axis to be ln of activity of zinc 2 plus over copper 2 plus, right? So if you vary the concentration, thus the activity of the two ions as x here, so you will get a linear slope, sorry, linear graph, right, where you have the slope of this linear fit to be minus RT over 2F, right? And you have here the intercept, which is the E naught of the cell, right? If you look at the intercept is at a point where the x axis is 0, where the value of ln activities of zinc 2 plus over activity of copper 2 plus is 0, and you will reach this term 0 when the value of the activities are 1. So this is exactly the definition of the potential at standard conditions. E naught, value of the x is 0 when the activities are 1. And if you look at here, the intercept at x, this is the case when you the system are at equilibrium. At equilibrium means that the E of the cell is 0, right? You are at y equals to 0, E cell equals to 0. Okay, so when at equilibrium, so E naught of cell is 0. At this point, you are at a standard condition of at E naught cell. So if you want to maximize your system, you want to be in the range as far as possible as this one. Okay, so that your E cell will be as high as possible, and you do this by having a very low activity of the zinc 2 plus or high activity of copper 2 plus, right? If this term is negative, then if this term is negative, then this would be positive, and you will maximize the E cells. This in the graph, you will be in this area. When you allow the reaction to happen, right, so the E of the cell will decrease until it reaches standard, and then it reaches equilibrium, 0 E cell, 0 potential, right? Because as you allow the reaction to progress, so if I write the net reaction again, zinc solid plus copper 2 plus over zinc becomes zinc 2 plus plus copper solid. So as you allow the reaction to progress, you will have the progress, meaning that you will be going to that direction, right? We're going to this direction, the reaction, forward reaction. As you move forward, the concentration or the activity of copper will become smaller, and the concentration or the activity of zinc will become higher, right? As a consequence, the value of ln activity zinc 2 plus over copper 2 plus will be more positive, right? Because as you let the reaction go forward, you will have less copper, right? Less copper, so smaller copper value, and more zinc, so bigger value. So if you have bigger value of zinc, then you have more positive term of the of this ln, and as a consequence your E cell will decrease until it reaches 0, and at this value you will, sorry, at equilibrium you will reach ln K, right? Because at equilibrium your E cell is 0, then at this value, at this point, that ratio of activity zinc 2 plus over activity of copper 2 plus is equal to K. So at this point you are at ln K.